Mills have and continue to present a serious danger in the rubber and plastics industry. Fortunately, through changes in work practices, safety engineering controls, such as pressure-sensitive body bars and worker training, the incidence of mill nip point accidents have decreased greatly. Injuries from mill accidents can result in permanent disabilities and sometimes death. Because of the nature of these injuries, it is critical for every facility to adopt and practice a rescue procedure that provides a means to remove a trapped and injured worker from the mill, and in a manner which hopefully minimizes the severity of the injury. After you watch this video, you may have questions concerning the procedures and equipment in your plant. Supervisors, safety representatives, and health and safety committee members can provide you with additional information to address your specific concerns. Before we review mill rescue procedures, let's discuss the basics of a two-roll mill and its safe operation. A mill is a machine consisting of two adjacent metal rolls set horizontally which revolve towards each other as viewed from above the mill. A mill is used for the mechanical working of rubber compounds. The mill process shapes the rubber into flat, long strips by forcing it through the nip of two set rolls. When discussing mills in plant safety meetings or written safety manuals, we often refer to the nip point of the mill. The nip point is a line formed where the two rolls come together. The inward motion of these rolls pulls the rubber through the mill. This same inward motion has the capability of pulling a glove, a knife, or an operator into the nip point. In addition to being pulled into the nip point by the motion of the empty rolls, an operator might be caught in the rubber being worked on the mill and pulled into the nip point. There is also a possibility of slipping or falling into the nip point of the mill. In some other cases, workers have been injured attempting to retrieve tools such as a glove or a mill knife which has fallen onto the mill. Workers who have been involved in a mill accident often state that they did not have time to react after being caught. Today, the most common protective step in minimizing or preventing the risk of being caught in the mill nip point are fixed or pressure-sensitive body bars. Sometimes this protective device is referred to as a belly bar because the device is installed 40 inches above the working surface, or above the level of an average employee's stomach. This height allows the worker to operate the mill but not reach the nip points. If an employee is caught in the rubber or pulled into the nip point, he or she can stop the mill's rotation by activating the pressure-sensitive body bar. OSHA has mandated a maximum stopping distance based on roll speed. This distance should be determined for every mill in the plant by management with the assistance of the Health and Safety Committee based on OSHA and ANSI standards. The stopping distance should be checked on a weekly basis. An emergency safety rope or cable may be used alone or in conjunction with the body bar to stop a roll. It is important to note that a cable does not provide an effective means of protection as a pressure-sensitive body bar. When mills are manufactured, means are provided to easily remove a worker if trapped. Each plant needs to develop a method or protocol for such extractions. An effective mill rescue program should include established procedures which take into consideration proper tools and equipment readily available in the immediate area. Alarms, a trained employee rescue team, and available medical and first aid resources. An emergency tool cart or mill rescue cabinet should be located in the vicinity of the mills. It should be designed so that its contents are readily available. Regardless of the procedure being used, some tools are needed. It is important to ensure that the mill rescue tools are inspected regularly so that they remain in proper working order and any missing or poorly maintained tools can be replaced. Mill rescue tools should include sledgehammers, pinch bars, wedges, insulated blankets, knives, rubber hooks, a bloodborne pathogen kit and other first aid supplies, a flashlight, and hydraulic jacks with spacers. A checklist of tools must be maintained and available for routine inspections. Every employee must be made aware that these tools are there to be used only in case of a mill emergency or a mill drill. The mill rescue toolbox must not be locked. This could delay rescue. However, some facilities use a breakable lock or seal on the toolbox to discourage unauthorized use of the tools. A rescue team assigned to cover given mills and calendars should be selected from among the employees familiar with the equipment and working in the immediate vicinity of those machines on each shift. Once rescue personnel have been trained and the equipment has been provided, they should hold practice sessions at regular intervals. In the course of such drills, each team should rotate mills used for the drills. Such rotation will help to ensure that all machines can be opened the minimum distance required to effect the rescue. The training should be developed with input from all mill operators, the Health and Safety Committee, and management. Quick, knowledgeable response can certainly reduce the severity of a mill accident. The members of the mill rescue team must become familiar with the mill rescue tools. Written rescue procedures should be established and posted. Mill employees should be knowledgeable of these procedures. A mill rescue team must be familiar with the actual hands-on rescue procedure and not rely solely on written protocol. When arriving at the scene of the emergency, the mill rescue team may assume their responsibilities for the rescue operation by predetermined assignments. It is important to consider that one of the rescue team members may be trapped in the mill and not able to assume his or her role. Also, other operators assigned to the important roles may be in other areas of the plant or off work. The mill rescue procedures should allow for alternates in all emergencies. Another possible option provides that the rescue team assumes responsibilities of the procedure in the order that they arrive at the scene. The following sequence depicts a mill rescue procedure utilizing the mill breaking or roll opening method. Following an accident, an employee will sound the alarm. This signal may be tied into the emergency stopping device. A co-worker who witnessed the mill accident or found the trapped worker may start the alarm. Whatever the type, system, and alarm used in your plant, it must be distinguished from other plant emergency alarms. The alarm notifies members of the mill rescue team and other plant personnel of the emergency. The first person arriving at the scene should ensure that the mill is stopped. This may be done with the belly bar, safety cable, or the emergency stop on the control panel. If the alarm has not sounded, he or she should do so. The second rescue team member arriving at the scene with the emergency tool cart should protect the injured employee from being burned by the hot mill surface or hot rubber. To protect the employee from serious burns, a thermal blanket should be placed between the victim and the mill. The rescue team member handling the blanket should remain with the victim, offering comfort and support, including restraining the injured if necessary. This person may also be assigned the responsibility of cutting the rubber away from the victim, being sure not to cause further injury to the body part trapped in the rubber. As additional rescuers arrive, one should remain at the manual reset emergency switch to ensure that the mill is not restarted or reversed. Others should make sure that the tools are properly distributed. A rescue team member should contact appropriate emergency personnel to secure the necessary emergency and medical services. An effective mill rescue involves the rapid but orderly process of opening the mill rolls. Rescue team members must secure and insert the mill bars into the mill screws. The mill screws should then be rotated to enable easy removal of the mill caps or plates. It is important to ensure that the screws are lubricated and maintained properly on all mills. The mill caps must be removed to allow sufficient space for additional mill roll movement. If this is not done, it will impede the opening process. These caps provide the means of immediate mill screw clearance. Mill jacks, either permanent or portable, can be used once the mill screws are opened and the mill caps removed. Where permanently mounted jacks are provided, one rescue team member must activate the pump handles. It is important that the pumping action be applied simultaneously to both pumps to prevent cocking of the mill rolls. When sledgehammers and wedges are the primary tools used for opening the mill rolls, or in the event of a jack failure, two rescue team members should set a wedge into the mill bite at each end of the mill from the opposite side of the victim. The wedges should be forced into the mill bite using the sledges simultaneously to prevent cocking of the mill rolls. Once the mill rolls have been opened, the rescue team members should lift the injured from the mill and administer first aid until emergency medical or other qualified personnel arrive at the scene and assume the responsibility for medical care. The victim must be treated and stabilized before transport to the designated emergency medical facility. Competent medical or first aid personnel should be available to respond in the event someone is caught in a mill, to treat the injured person for shock, and to properly prepare the injured body part for transporting to the proper medical facility. Because workers are sometimes more seriously injured by the heat of the mill, the reversal method of freeing the worker has been employed in some facilities. In particular, where plastic compounds are milled, the worker can be freed by reversal much more quickly than the mill breaking procedure. There is also concern for the portion of the body trapped in the bite of the mill. This part of the body will be rolled through the mill again as it is reversed. Before procedures can be developed for mill reversing, the operators, safety committee members, and management should do some planning. Instances have occurred where mills have been activated forward instead of reverse during the rescue process. What controls will be used to reverse the mill? Will this control work after the safety devices have been activated? How far will the control turn the mill? Where is the trapped worker? If he is on the bottom side of the mill, the procedures used to remove him must be different. These and other concerns must be addressed and worked out before procedures such as this can be effectively implemented. Both methods must be instructed, prepared for, and practiced, because circumstances may arise which will prohibit the rescue team from reversing the mill. Please note that care must be taken to keep the worker from the heat of the mill. A blanket cannot be used as it may be pulled into the bite of the mill on the bottom side of the rolls. A team member in this rescue will remain at the main control panel to operate the reversing action when needed. This particular mill has been fitted with an emergency reverse control switch to ensure the mill only moves in reverse. The emergency reverse is a red button that is concealed below a glass safety panel. The mill being used in this demonstration will operate in a jog reverse mode when this button is activated, even after the safety switch is actuated. This button can only be operated when the safety glass is broken. The jog reverse button will move the mill approximately 2 inches each time it is pressed. By jogging the mill in this direction, the worker is free from the nip point. In some cases, the mill motor will not allow a jog reverse function when the body bar is activated. Some mills have slightly different procedures. Be sure to note the differences in your site-specific training. Do not reverse the mill if a worker is trapped beneath the mill. It is important to note that some circumstances may require that the mill be opened instead of reversed. During an exercise like a mill rescue drill, much activity occurs in a short time period. It is important to spend some time now becoming familiar with the proper procedures so that the few minutes following an accident go smoothly and the operator is freed from the mill as quickly as possible. Each of us can do our best to prevent accidents such as these in our workplaces. When an accident occurs in a plant, there are more than likely many factors that contribute to its cause. A mill rescue team must be prepared to respond to various types of incidents on any mill in the plant. We all share one common goal. We all hope to leave work every day in the same condition as when we arrive. Just as importantly, we all want to ensure that procedures are in place and personnel are adequately trained to properly respond to emergency situations which can minimize the severity of an injured coworker.